Hi, welcome to the Technology Modernization and Innovation Conference. My name is Anthony Catanese. I'm the product lead at SourceFuse Technologies located in Jacksonville Beach, Florida. I've started off my career working as a front-end web dev for a multitude of years and then found myself in the product world. Um, Over the course of that career, I had a chance to work with a lot of small startups with anywhere between 3 to 14 people to working with very large enterprise organizations with hundreds of thousands of employees around the world. And I love getting into the tech side of things and like really getting in deep. At SourceFuse, we're a cloud native organization and we're an AWS advanced consulting partner with 15 years of experience working with the industry's best delivering digital ready modern products. Uh, our clients hire us for our deep cloud expertise end-to-end services in application migration and in modernization. We have a lot of partnerships, some with like Vonage and Twilio, as well as groups like Loopback, which we'll talk about in just a little bit. So when we say defining modernization, like what does that really mean? Like what is modernization? Uh, for us, it's more than just doing a quick update. It's about bringing your entire enterprise up to speed with the digital environment. It's maybe looking at your whole portfolio to measure, what quality and business value you're bringing to the table. You may have to rewrite and port a bunch of different legacy systems with modern languages. Um, but the big thing is that you want to improve your bottom line and also lighten up the load on what you're putting on not only your teams, but on your systems. So when clients come to us, and this is a lot of times the pathways that we see for going from, say, Microsoft over to um, an AWS system, we see that it really happens in two phases, or at least happens in two pathways. One is in a .NET application, which we will typically move from just standard .NET to .NET Core, open source, moving to containers moving to Linux containers, and as well as re-architecting more into serverless, which we'll talk more about what serverless is. If someone was to come to us with SQL Server, we do something in a very similar way. We move again over to more of a SQL Server Linux, optimized for SQL Server on RDS, and we'll also get into re-architecting with open source items. Okay, so let's talk a little bit about microservices. So when you're looking to really like break down and modernize your portfolio, microservices are a way that you could go about breaking apart your giant monolithic applications and getting them into smaller, more maintainable bytes. So microservices architecture is an approach to developing a single application as a suite of small services, each running its own process and communicating with lightweight mechanism. So what you'll see here in the middle is the monolithic architecture. So most startups, small businesses, and enterprises have built or have been building monolithic applications by analyzing a problem statement, and then they just start building towards it. And this usually works. Like this works really, really well if you have a very specific use case that doesn't plan on growing or adding features. If it's a very specific thing that you're looking to build, then it's solid. Um, one of the main issues is that this inner structure of the app consists of a database, a client-side interface, and the business logic. It all sits tightly coupled together with no APIs to communicate. It just operates as one whole. Well, an issue with that is that if something was to break internally, the whole thing breaks and fails all at once, as opposed to being able to fail at different segments. Monolithic architecture is an apt choice for small size applications with benefits of having a single code base with multiple features, functionalities, but that soon becomes chaotic and uncontrollable as the application begins to evolve with additional features and functionality, as I said before. So here on the right, you can see that within microservices, what you tend to do is you break out the UI, from itself, but also you have the business layer and the data interface are speaking separately across multiple different databases and calling different aspects of the application at any given point. What that allows you to do is it allows you to get to market faster, since development cycles are shortened. You don't have to develop for the whole application all at once. You can do it for just one microservice. It's scalable, so you can add more services as needed. So you can add as demand for certain services grow. You can deploy across multiple servers and infrastructure to meet your needs. They're resilient. These independent services, when constructed properly, do not impact one another. This means that if one piece fails, the whole app doesn't go down, unlike the monolithic app model, which I said before. And they're also easy to deploy. Because your microservice-based apps are more modular and smaller than traditional monolithic apps, the worries that came with those deployments are negated. They're also very accessible. Because of the larger app is broken down into smaller pieces, developers can understand what's happening inside that microservice much easier, so that they can easily update and enhance those pieces, resulting in faster deployment cycles, especially when combined with agile development. And then more open. Due to the use of polyglot APIs, you can use a multitude of languages when working throughout the application. So developers have the freedom to choose the best language and technology for the necessary function. Okay, so let's get into one of the main features of modernization that empowers microservices. And one of those is serverless cloud architecture. So serverless architecture allows teams to build and run applications, but not manage any of the infrastructure. Provides a way to remove architecture responsibilities from their workload, including the provisioning, the scaling, and the maintenance. Scaling can be completely automatic, and you only pay for what you use, which is fantastic. One of the advantages of going serverless is the ability to have observability into your system, being able to see all the different logs and where everything is broken, as well as it being event-based. So what I mean by event-based is the system with an event-based architecture, each subpart of the application is completely independent. So events trigger one another. In monolithic, older school applications, everything is stream-based. So there are connections to each service. If there is a failure, it just impacts that event as opposed to the whole entire thing falling down. Faster deployments and greater flexibility. So if you can rapidly deploy apps in hours because there's no infrastructure and construction to weigh you down. With faster deployment also comes easy scalability, as I mentioned before. By using such an agile architecture, you can be very flexible in your releases. Because it's a quicker process, you can accelerate innovation. So you can release in just a couple of minutes, as opposed to waiting many, many days to procure new hardware. Also, a massive benefit is cost reduction. Being serverless, an organization is essentially outsourcing your server and database management. You're no longer responsible for huge investments in maintaining internal architectural admin. Ultimately, your use case will define how much you can save. But there are limitations. One limitation to serverless is long-running application inefficiencies. So if you're looking to spin up something, like you're looking to spin up a function that's only going to last for half a second, that's great. You spin it up, run the thing, turn it off. But if you have something that's going to run for an hour, you're using a very expensive method for running that particular application or that service. So, it's probably not a good fit if you have a lot of long-running applications. Third-party dependencies, serverless architecture requires you to be reliant on your provider. So you don't have full control, and changes may impact you without notice. The platform's availability is subject to its terms. And then cold starts. So a cold start occurs when a platform must initiate internal resources. It may take some time for the serverless architecture to handle the first function request. You can avoid a cold start by ensuring the function remains active by just constantly pinging it. But cold starts are something that you have to keep in mind when you're going through and redeveloping. So let's talk about serverless when it comes to AWS. For SourceFuse, we heavily rely on Lambda for all of our applications. Lambda has a lot of different flexibility, but one of our favorite things is the fact that it can use a lot of different languages such as Node, Python, Java, C# and PowerShell. And what we do is we essentially package up all of the functions that we need within the Lambda and then expose them through public consumption using Amazon API Gateway. Uh, the events that are triggered and the costs are also substantially low. So let's think about a function where you want to receive notifications in Slack if you're having issues within your system. So there's a minimum, like let's say there's a minimum memory setting of your system of 128 megs. So there's a Python function that simply on receiving an AWS CloudWatch alert notifies the AWS SNS, which further triggers the AWS Lambda function to send the notification via Slack. It runs in under 100 milliseconds. The execution time charged will only be 100 milliseconds, and the estimated charges for 10 million executions of that function are only $2 a month. So you're able to create a notification directly to your team very quickly, and also for it not to cost you an arm and a leg. On the previous slide, we talked about some issues that you may have with serverless, and one of them being cold and hot starts. Well, recently, Amazon came out with some new products to be able to. Recently, AWS launched AWS Lambda Cold and Hot Start, which have significantly improved the performance issues. Once a cold start feature in Lambda is chosen, the AWS Lambda will essentially remain on for about 5 minutes, allowing any other call not to have to wait for this initiation for each time. Calls made during this period are called warm calls, which means that the code is loaded into memory and ready to be executed when the AWS Lambda is called one or several times. Also, running Lambda on your local systems is now possible using SAM. So running on local cloud, AWS SAM Serverless Applications Model, CLI, has become the core of launching serverless locally, which is extremely helpful. This is all written in YAML to make it nice and clean and less cluttered as possible. And by calling the AWS Lambda locally using SAM CLI, you'll pass to the AWS Lambda either through the output of the SAM CLI generate event command or by passing JSON file with the static data. And SAM requires Python, Docker, and AWS CLI. So to make sure that we're staying on top of everything within SourceFuse itself, we help our clients modernize, but we also too want to modernize ourselves and make sure that the tools that we're working towards and that we're developing are things that we would use ourselves. So one of those is SourceLoop. SourceLoop is an open source framework for development of modern cloud native enterprise applications. This is something we've partnered up with Loopback for and kind of forked our own version of it to be able to create our own microservices, such as like if you want to have a login or if you need a video service, we have these different modules that we can use inside of this framework. So if we need to spin something up really quickly, we've built that video service before, we can grab it. We've built that, that login process, we can grab that, we can bind them together. And so we can deploy technology very, very quickly. And we still get the same type of support that Loopback 4 has been getting from IBM, because that is the core of everything that we've been doing. So it's cloud ready, it's auto scalable. There's no vendor lock-in, which is great because again, it's open source. And then really it empowers business and it empowers our clients. And we appreciate the community that builds around it. And that takes me to my last point. So one of the main reasons why we go after the technologies that we do is because everything that we do is based on people that build our products, and not just our products, but our clients' products. So SourceFuse, we're a service organization, and the people that are delivering that service have to be really excited about the work that they're doing. And so the hidden superpower of modernizing and working in these communities and using the newest language is that you get all of the opportunity to work with communities across the world and a ton of different channels. 4 very obvious channels right now is Discord, Slack, Meetup, and Stack Overflow. The newer languages that you're using, the more modern approaches that you're taking, get people very excited about the type of work that they're doing, and also it gives them a chance to talk about it in groups that they already belong with. we also use these highly for hiring and trying to find the people that will fit best for us. So with that, thank you and look forward to the Q&A.